Hi, welcome back. This is Balu here once again. Today we are going to talk on part 3 of software design. Let me quickly put you onto the objectives. We are going to talk about control modeling and modular decomposition. So we have already seen about the architectural design process in our previous session, and we have seen that an architectural design process would involve three activities. The first activity is called as system structuring. The second activity is called as control modeling, and the third activity is called as modular decomposition. We know what system structuring is, and we have dealt in elaborate in my previous session. If you haven't watched that session, please go watch that session and you can come and review this particular session for future. Now, what exactly system structuring? If you want me to put me in a nutshell, a system structuring is basically breaking down the entire system into number of subsystems. And in order to do that, we have seen so many supporting models like the repository model, the client server model, and the layered model. So today we shall focus more on what is control modeling and what is modular decomposition. So what is control modeling? Control modeling is used to identify control relationships between parts of the system. We know that a system is made up of many subsystems. So we also need to know how two subsystems are interacting with each other. What is the controlling relationship between the two subsystems, and if you want to do that, we need to understand the control modeling of the subsystem. And also we have to also focus on modular decomposition. What is modular decomposition? Modular decomposition is a process of decomposing the systems into modules. So we'll look at modular decomposition in detail when we are actually coming to the end of this particular session. Now we'll talk more about control modeling. As I told you, a control modeling is basically a model of control relationships between the different parts of the system which is established. That means a system is a combination of many subsystems. The control relationship between the two subsystems are actually published using control modeling, and they are also concerned with the control flow between the subsystem. What is the control flow between the two subsystems are actually depicted in the control modeling. And there are two types of control modeling which is of importance. The first one is called the centralized control, and the second one is called as the event based control. So we shall see what is centralized control and what is event based control. Now, what is a centralized control? One subsystem has overall responsibility for control and starts and stops other subsystems. See, what happens is, as I told you, a system is a combination of many subsystems. Somebody has to take the control of all the subsystems. Subsystems cannot work independently. Somebody needs to control those subsystems. So one subsystem controls all other subsystems. So if this concept is there in picture where one system is controlling all other subsystems, then we call it as an centralized control. And there are two types of centralized control. We call them as the call return model, which is predominantly used for sequential systems, and managerial model, which are used for concurrent systems. Sequential systems where the subsystems are evaluated sequentially, that is one after the other. Concurrent systems are those where subsystems can run in parallel. We'll look into more details when we actually talk about call return model and manager model. Now, here is an illustration of how exactly an call return model works for sequential system. Know that it is an example of an centralized system. So you can see from this call return model that you have a main program. This main program is actually calling routines, routine 1, routine 2 and routine 3. Now what are these routines? Routines are nothing but subroutines, or you can also call it as a function, or it can even be a procedure, or if you want to put it straight, you can even call it as a subsystem, which means the main program calls subsystem 1, the subsystem 1 calls subsystem 1.1, which means the flow of the control is happening downwards in a hierarchical order. Now this is what you mean by centralized control call return model. Okay. Now similarly, you can see one more sequential order coming here. The main programming calling routine 3 and routine 3 is in turn calling routine 3.2. So there is a sequential hierarchical control which is happening from the main program to the bottom routine. So this is an example of an call return model. Now to illustrate this call return model, I have actually written a Java program. I will show you how this program is written and how you can actually justify that program to this call return model. Okay, now let me flip over to the program quickly. Okay, oops, it's here. Let me zoom this a bit. Okay, now see here. Now I have a class called nest. Okay, in this particular class called nest, there is a constructor. You know that the constructor will have as the same name as the class, and this constructor is actually initializing the values of m and n. I have two methods. One is called a large method, which will find out which is the largest of two numbers among the variables m and n. And I have another method called display, which will actually print the largest of two numbers. Now we know that the Java program execute using the main method. Now this is my main method, public static void main. I am creating an object called O1. Now this is an object called O1 which is created of the class called nest, and I am passing the value 100 comma 200. So what happens, a constructor method is called, so where the value of x and y will be initialized to m and n, which means that the m will be initialized to 100 and n will be initialized to 200. That is pretty straightforward. Now what is point of importance here is, you just observe here, using this object O1, I am calling this method called display, O1 dot display. So this is a display method. Now this display method is in turn calling a large method. So now just recall what exactly happens in sequential control. The main method calls a method, and that method in turn calls another method, or the main method calls a subsystem, or that subsystem in turn calls another subsystem. So in this case, this display method is actually being called, and this display method is in turn calling a method called large. So what we are doing in the large method is, we are trying to find out the biggest of two numbers among m and n. If m is bigger than n, it will return the value of m, and if n is bigger than m, it will return the value of n, and that is actually being printed here as which is the biggest number. Now this is an solid example of this particular model where we will call it as an call return model. Let me flip to the PowerPoint now. Okay, so now we understood what is a call return model, which are predominantly used for sequential systems where the control happens in the form of hierarchy. Next we have something called as a manager model, which are used for concurrent systems. Now whether it is a call return model or a manager model, please understand that there has to be one subsystem which controls all other subsystems. Now in case of a manager model, you have a subsystem called system controller, which is actually controlling all other subsystems. Now here sensor process is a subsystem, actuator process is another subsystem. Like this you have multiple number of subsystems, and these subsystems basically are working parallelly. That is, if subsystems run in parallel, then we would require a manager to control the subsystem, and that subsystem is nothing but the system controller here, and starting and stopping of the system is controlled by the manager. Now if I want to start this sensor process, it is controlled by a system controller, and if I want to stop the sensor process, that is actually controlled by the system controller. Now we have illustrated an example here. Now this example is a block diagram of a smoke and a fire detecting system. Now as you can see, there are multiple subsystems here. Now you have a smoke chamber which has got an IR receiver, that is one subsystem. Then you have an audio alarm, which is another subsystem, system power another subsystem, and the communication module, which is another subsystem. We are not worried about the actual implementation of these subsystems because we are not that much concerned about electronics here. Now we are trying to relate this electronic block diagram to one software engineering practice. Now what will happen here is, now the moment this particular the moment that this particular subsystem senses either a smoke or either a fire, automatically what happens, there will be a data transmitted to the main control. Now this main control subsystem automatically activates the alarm. which means you can see that now the starting of the audio alarm depends upon the input received by the sensor, and the sensor receives an input if there is actually a smoke or a fire. Now once the smoke or a fire is reduced, the audio alarm is put off, and now assuming that that audio alarm is on, the subsystem also activates a communication module where it can send an communication via an SMS to the owner of the building stating that there is a fire in the office or a building, and once the fire has stopped, the message can be also sent that the fire has now come into control or the smoke has now come into control. Now this is a simple example of a centralized control manager model concurrent system. Now there is another type of control modeling which is called as an event based control. Now what exactly is an event based control? As you can see from the slide, driven by externally generated events where the timing of the event is out of the control of the subsystems which process the event. Now we know that there are events which are happening outside the subsystems. Now the subsystems will only act only when the event comes into picture. If there are no events coming into picture, then the subsystems don't act at all. Now there are two types of event based control subsystems. They are called as the broadcast models and the interrupt driven models. Now we shall see in elaborate what is a broadcast model and what is an interrupt driven model. Now first we will see what is an broadcast model. Now in case of a broadcast model, the name as it implies, broadcast. Broadcast means sending the information to many. Now there are many subsystems. You have subsystem 1 to subsystem 4. In reality there could be n number of subsystems. When there is an event happening, now that event is broadcasted to all the subsystems. Now if a subsystem is programmed in a way to pick up the event and perform a process, that subsystem will actually pick up the event and perform a process on that particular event. Those subsystems which are not programmed to actually pick up the event, they are just they are listening to the event and they will keep quiet. Now this is an example of a broadcast model. Now have a look at this small code snippet and a graphic which I have shown here on the right hand bottom of your screen. Now there is an event source called a button. So now what is a button? This button could be a simple command button. When I click on a command button, clicking of a command button itself is an event. Now when I click on a command button, I need to perform some action. Now you must have observed this. You have command buttons in login screens, you have command button in registration pages, you have command button called OK and cancel. Now when I click on a command button, some action should take place. So when I click on this button, an event has been triggered. Now that event is actually broadcasted to the entire subsystems. Now that subsystem or a program snippet which basically controls this particular button will be activated, and whatever functionality you have defined as a programmer, that functionality will be executed. Now I have explained this event based control and in that broadcast model which I am trying to relate to your layered architecture. If you remember, we had dealt about this layer architecture in my previous session. Now what is a layered architecture? Any architectural model or any model which has got 3 layers or more than 3 layers is called as a layered architecture. Now in this case you have a presentation layer and a business layer and a data access layer. Now all these layers can be called as subsystems. Now what is a presentation layer? It is a user interface. Business layer is a layer where all your business objects and business transactions are defined, and you have a data access layer where you have got connectivity to the database. Now there is a registration form which is here, and in this registration form the user actually fills up the username, fills up the first name, fills up the second name. He fills up all the details which are normally there in the registration form, and registration form actually relates to the presentation layer because it is the form which is actually being thrown to the customer or the end user where the user is trying to fill up the form. Now once he fills up the form and clicks on the submit button, an event occurs. Now this event is actually broadcasted to all the subsystems. It is broadcasted to presentation layer or a subsystem, or a business logic layer or a subsystem, and a data access layer. Now these subsystems are actually, if at all they are actually programmed, or if they are actually functionalized to actually handle this particular event, then they pick up that particular event. Now presentation layer picks up the event. Here, for example, it will identify what data is fed in first name and last name. It will actually transfer that data to a business logic layer. Business logic layer uses some validation rules of the business and transfers it to data access layer, and the data access layer finally transfers the data into the database. Inside the database it is actually pumped that particular data into a table. Now this is called as an broadcast model. So broadcast model is an example of an event based control which comes under your control modeling. Now there is one more control modeling event based control which is called as an interrupt driven control. First know what is the meaning of the term interrupt. So interrupt is nothing but an abrupt signal given to the CPU. So we know that CPU is handling multiple processes. Now what is a process? Process is nothing but a program in execution, or we can say that the CPU is handling multiple tasks. When the CPU is handling multiple tasks, we call it as multitasking. Now there could be a signal given to a CPU to halt that particular task for a while and service the particular interrupt. Now any signal given to a CPU abruptly is called as an interrupt. For example, you must have used this interrupts unknowingly. You are actually working on a software. Suddenly the software gets hung. So what exactly you do now? You go and press Ctrl Alt and Delete. When I press Ctrl Alt and Delete, what happens? This Ctrl Alt and Delete becomes an interrupt. Now as soon as I press Ctrl Alt and Delete, what happens? The CPU will stop the normal execution of the task and it will go and service the interrupt. So like this, could be multiple interrupts which are coming from different parts of the system, and all the interrupts are actually put in a queue, and we call that as an interrupt vector. And know that all interrupts will be prioritized, which means that each interrupt would be having a value. Now the lower the value, higher is the priority of the interrupt, which means that if the interrupt priority is 0 and the priority of that interrupt is high, and if the interrupt value is 5, the interrupt priority is low. Now what happens now, once the interrupt is encountered, there will be an interrupt handler and there will be a process to handle that particular interrupt. If you want me to give you another example, washing machines are the best examples of an interrupt driven model. So what happens in a washing machine? You put the clothes, you put the water, you put the washing powder, you start the power and start washing. Now what happens when the process of rinsing is going on? Let us assume a situation where the inlet to the washer or the washing machine, the inlet of water is cut off. The moment the water is cut off, what happens? The rinsing cannot happen, because rinsing cannot happen without a water. So immediately what happens? The interrupt is raised. The moment the interrupt is raised, the processor, what it will do is it will stop the rinsing and it will start giving a beeping sound. Now this is an example of an interrupt driven model. Okay, now what is modular decomposition? Now you know that in architectural model we basically did system structuring, where we identified the subsystems. Then we did control modeling, where we identified the control relationship between the subsystems. Now the next stage would be your modular decomposition. Now modular decomposition is a process where you convert all the subsystems into modules. Now if you ask me what is a module, at this point of time I can say you that module is a part of a program, or many programs put together becomes a module. Now module decomposition models are of two types. We call them as an object model and a data flow model. Now we shall focus on what is an object model and what is a data flow model. Now what are object models? Structure the system into a set of loosely coupled objects with well-defined interfaces. Now object model itself is an outcome of object-oriented decomposition, where all the subsystems are visualized as objects. Now what are objects? Objects have certain properties and methods. We shall look into a diagram of an object. Now for this point of time, understand that the object-oriented decomposition is concerned with object classes, their attributes and operations. Now have a look at this particular object model. It is of a case study called invoice processing system. Now this is an invoice object. Now as I told you, an object will have two sections which are very prominent. The one is called the property section or the attribute section. The second one is called as the functionality section or the method section. Now this invoice object is actually communicating with other objects. Now invoice object is communicating with customer object, with payment object and the receipt object. So we call this as object communication. Now how customer object and invoice objects are connected with each other? Very simple. If you want to, if I want to issue an invoice to a customer, now I basically make use of an issue method of an invoice object to talk to the customer object. Now once an invoice is issued to a customer, the customer has to make a payment. So the payment object talks to the invoice object, and the invoice object accepts the payments through an accept payment method. Similarly, once the payment has been accepted, a receipt has to be given to the customer. So now the invoice object talks to the receipt object, where you are going to send the receipt to the customer using an send receipt method. So this is a simple illustration of how objects communicate with each other, and how object level decomposition can really help in visualizing the subsystem into an object models, and object models gives a great clarity in designing the programs. Now the second type is called as data flow model, which comes under your modular decomposition. What do you mean by a data flow model? Simple. The entire system is actually transferred into functional modules, which transforms input to an output. Now there are some functional modules here. Now you can see you have read issue invoices, that's a functional module. Identify payments is a functional module. Now every functional module will do one thing. What it will do, it will basically transfer an input to an output. Now read issue invoices. So this module is actually reading the invoices. To read this, it needs an input, and the inputs are nothing but invoices. Now in turn it will call identify payment functional module that requires an input called payment. Now this identify payments will in turn call issue receipts and find payments due functional modules. Issue receipts will have an output called as receipts, whereas find payments due will in turn call another functional module called issue payment reminder, and the output is nothing but a reminder. Now this is called as a data flow diagram, and one more example of modular decomposition where the entire subsystem is broken down into number of modules. Now quickly I am going to summarize what we have done in the architectural design so far. Now we know that architectural design consists of three levels. We had system structuring, control modeling, and modular decomposition. Now system structuring, we saw repository model, where we had two flavors to that. One is the shared database, and the second one is the individual database, where the database was in a central place. And we looked into the client server model and the layered model. Now control modeling had two levels. One is the two types, one is called the centralized control and the event based control. The centralized control can be further classified as call return model and the manager model, and the event based control was actually classified as broadcast model and interrupt driven model. And the modular decomposition was again further can be modeled in two different ways. One is called as an object model, and second one is called as the data flow model. That's it for today. This is the actual process of architectural design. I will conclude the session as of now. I will see you in the next session, and we are going to look into the more concepts of software engineering. Okay, thank you so much for watching this particular video. Please don't forget to subscribe to our channel SP Tech, and do like us on our Facebook page SP Tech BANG. I will see you soon. Thank you. Bye bye.